I want to talk with you now about big data tools, or at least the open source big data tools that became incorporated into modern cloud platforms. First, let's take a look at the evolution of big data tools. With the rise of big data, companies faced new challenges in processing, storing, and analyzing vast amounts of information. Traditional systems just weren't able to keep up with the scale and the complexity of this data, so new solutions were needed. In response, different companies began developing a wide variety of tools to meet these challenges, establishing new standards for how big data is handled. And then these tools helped to streamline large-scale data processing and analytics across the industry. Eventually, many of these tools became part of the Apache ecosystem, which is a collection of open source solutions designed to address big data problems. The Apache Software Foundation has played a key role in organizing and maintaining these tools and making them widely accessible to the tech community. Let's take a look at the three key principles that defined most of the development of these big data tools in the Apache ecosystem. The first is distributed or parallel processing. Big data tools are designed to break down massive data sets into smaller tasks that can be processed across multiple nodes in parallel. This allows for faster processing and the ability to handle enormous volumes of data efficiently. So the icon here represents a central node distributing tasks to several smaller nodes to process data in parallel, showing how parallel processing works across a cluster of machines. If you've heard the word cluster, this is a cluster. Next, we have scalability. So big data workloads are not static, as you may already know. They grow, and when they grow, they often grow rapidly. When they shrink, they also often shrink rapidly. So scalability refers to the ability to expand or contract either by changing the number of nodes, which is horizontal scaling, or by increasing or decreasing the power of existing nodes, which is vertical scaling. The upward arrow here in this icon symbolizes the system's ability to grow and adapt as the data and processing demands increase. But again, scalability also involves decreasing the number of resources if the amount of data is decreasing. Finally, we have fault tolerance. In distributed systems, failures are inevitable, whether it's a node going down or a network issue. So big data tools have built-in fault tolerance to ensure that if one part of the system fails, the rest continues to work seamlessly. Think resilience and the ability to recover from failures. This ensures that your data processing jobs keep running smoothly. Together, these three principles, distributed processing, scalability, and fault tolerance, became foundational to the Apache ecosystem. They're not the only important principles, but they're the most important and most common among the tools. Over time, Apache tools converged on these shared concepts to address the growing challenges of big data. It's not that someone just sat down and kind of thought of these and put them forth as the principles that other tools should follow. It emerged gradually over time from as a common aspect of these solutions that were being developed to deal with big data. This convergence allows Apache tools to work efficiently across various environments. So that makes them highly adaptable and powerful solutions for large-scale data operations. Now let's talk about the relationship between these open source big data tools that were developed and modern cloud platforms. Previously, these Apache tools were only run on-prem, but as cloud platforms grew, many companies began offering on their cloud platform managed versions of popular open source tools. So this allows users to access the same open source technology they're familiar with, but without the operational overhead of managing and maintaining the infrastructure, which is what you would have to do on-prem. For example, GCP has built a suite of services that are essentially beefed up versions of these open source tools. They provide additional scaling, security, performance optimizations, all managed by Google, so you don't have to worry about manually handling these aspects. And these managed services allow users to leverage the power of open source frameworks with the ease of cloud automation and maintenance. This means that you can still benefit from the flexibility and the community support of open source tools, while relying on GCP to take care of the infrastructure management and scaling. Okay, this slide shows how GCP offers managed versions of popular open source Apache tools. We have Apache Kafka, which handles real-time data streaming. Its GCP equivalent is Cloud PubSub, which is a fully managed messaging service that automatically scales. Next, we have Apache Beam, a model for both batch and stream processing. And in GCP, Cloud Dataflow manages Apache Beam, providing auto-scaling on batch and stream pipelines without the need for infrastructure management. For Hadoop and Apache Spark, these are used for large-scale data processing and analytics, and GCP offers Dataproc. This managed service, Dataproc, simplifies Hadoop and Spark jobs by handling the management of clusters and reducing setup time, which is often associated with Hadoop and Spark jobs. For Apache Airflow, we have Cloud Composer on the right here. This managed service, Composer, simplifies running Airflow workflows by handling infrastructure, reducing setup time as well. And this allows you to focus on building and managing pipelines, also known as DAGs. Then we have Apache HBase, a distributed real-time database. It maps to GCP's Cloud Bigtable, offering the same high throughput and low latency benefits. And it's also managed by Google. Not NoOps, but managed by Google. Finally, we have Apache Hive, which is a data warehouse system. It's matched by BigQuery in GCP. This provides a fully managed serverless data warehouse with powerful SQL querying capabilities, just like Apache Hive does. So on the exam, you may come across questions that involve the migration from a system where an Apache tool is being used and instead to use the GCP version of the tool, essentially. Or they would ask you to migrate the solution to GCP. So understanding which GCP product corresponds to which Apache product will be helpful for the exam. And that's it for this section on open source big data tools and how they got converted to GCP services.